Okay, here we see our 2013 Audi A8L, and this has the 4.0 liter TFSI engine, and this is the direct injected gasoline engine, and this has the cylinder select feature, so I can actually disable 4 cylinders, improve fuel economy. Now, of course, we experience a catastrophic turbocharger failure. Now, the turbocharger here on the right side, the turbine wheel, which we'll show in just a moment, actually came loose from the shaft, and it horribly tore up the housing. So this is actually a replacement housing, and we purchased this there from our friends in mainland China, and they did a very nice job, and this looks like it's very pristine. I believe this is remanufactured. I don't think this is new, but it's certainly in excellent condition, no question there. Now, over on the left side, I didn't have any problems, so I'm using the original exhaust manifold and turbine housing. And of course, remember, this is a dual scroll turbo, so I actually have 2 nozzles here. One nozzle is fed by 2 of the cylinders on this bank, and the other nozzle is the other 2. And this is designed in such a way is that when I get a puff of exhaust through a nozzle, it will be for every other cylinder. So there, this will give a very smooth acceleration of the turbine wheel, going from a low speed to high speed. And that's the idea of using 2 turbochargers and the 2 nozzles. All right, now one of the things I had to do is that they did not give me these studs here with the remanufactured turbine housing exhaust manifold. So here I've used a stud, and this is a non-magnetic, as you can see, copper coated with a nice locking bolt. This is working very nicely. This happens to be 8mm, 1.25 threads per, I guess, millimeter. This is a metric application, obviously. Here we see the wastegate actuator and the wastegate, and I apply vacuum to actually close the wastegate, and the wastegate obviously has 2 sections for each of the nozzle sections. So we've got all this carefully installed, new gaskets, and I have new O-rings. Now, what I've elected to do, and I'll show it to you on the bench, is I've had, of course, this plate here taken off, all cleaned up underneath with a fresh gasket. I have a new crankcase ventilation system, which we'll show in just a moment. Here is the solenoid for the piston cooling nozzles. Yes, this is a series of nozzles that allow us to spray oil. They're at the underside of the pistons, help control temperature. By the way, the default for the solenoid, if I leave it unplugged or if it fails electrically, is to stay open, so it would continuously provide the piston cooling lubrication. Now, here underneath this plate, and I'll show it in just a moment, is a screen and a check valve. I did order a new one, but in careful looking at it and in the failure mechanism here on this vehicle, I have opted to leave out both the screen and the check valve. What happens is the oil lines are going directly to the oil gallery. Now, we'll look at these oil lines in just a moment. They're not even a foot long, so they'll drain back. But what happens, it's right to the main oil gallery, so as soon as the engine starts cranking, I'm going to get a column of oil up to the turbochargers. Now, these lines are actually cooling lines, and of course I have another set of cooling lines, and I have an electric pump that allows us to circulate coolant after I shut the engine down. All right, so here we're just about ready to go ahead and mount the turbochargers. One of the things I've elected to do is they didn't have much of a locating pin on the remanufactured turbine housing manifold, so I've elected to leave that off. That's going to allow me to position this anywhere I want it. And I'll go ahead and leave this one in. This is the original one from the original manifold, so that puts my turbine housing, or I should say my compressor cartridge, a central rotating assembly, in a fixed position relative to the turbine housing. Also, when I go back with the clamps, I want to make sure that the bolts are accessible there at the top. For some reason, they wanted to keep them underneath there on the original installation. So let's go ahead and move inside and take a look at our new turbochargers. Okay, here we see the remnants of the two turbochargers. Now, on the Audi 4.0 TFSI engine, they actually use a check valve. And this check valve connects to the main oil gallery, and when lifted off its seat, it allows oil to move up to the two turbochargers. And you'll notice that I have a screen, and when I looked at the screen, it wasn't necessarily stopped up, but as you can see, it's a very fine screen that apparently is really throttling the flow of oil. Also, something that was kind of scary too is when I push on this, there's some stiction there of the valve. In other words, I have to put a little force on it to get it to let go. And one of the things about the oil pump on this late model engine, it's actually a volumetric control oil pump. It actually is a vane type oil pump with a slide. And the idea is with the engine at idle, it lets the oil pressure drop to 29 psi to conserve fuel economy, maintains a specific volume but at a lower pressure. And then as I rev the engine and call upon it for higher load, it allows the oil pressure to climb. If for any reason this came down against its seat and starved the turbochargers for oil, you can see that it would very quickly destroy them. Now, this vehicle has well over 100,000 miles, but this is what we found. The turbine wheel had broken off, and apparently it had broken off in the turbine housing, and we didn't know that. We actually purchased the car like this. And the turbochargers feed into a common plenum, so I still have boost with one turbocharger. It just takes a little while to build it up. So as you can see, this turbine wheel was actually broken off and wedged into the turbine nozzle. Here we see its shaft. And the compressor wheel, of course, is making violent contact right here with the compressor housing. Now, obviously, we got a new compressor housing and new turbine wheel, and of course, obviously, turbine and turbine shaft. I shouldn't say turbine wheel, it's the compressor wheel. I did purchase the upgraded check valve, but I've opted to leave it out. There's nothing in there. It's directly to the oil gallery, and I'll show you there in the turbocharger bearing assembly, there are orifices already there. And you'll notice that some of the performance turbo manufacturers, they clearly state, do not, under any circumstances, restrict oil flow to the turbochargers. Not through a filter, not through a screen, direct to the oil gallery. And remember that my oil is filtered through my full flow cartridge filter. Now, what I did want to show here is the damage here to the turbine housing. We can see that when I took this apart, this was wedged nicely. Guess it's a good thing it didn't go all the way through, but it was wedged nicely there within the turbine housing. If it had fallen all the way through, I'd be trying to dig it out of the catalytic converter, which wouldn't have been pretty. So this has been replaced. All right, now we see what happens, and the vehicle does have well over 100,000 miles on it. Apparently this is a real common problem with the Audi, but it can't happen again on this next one. And now we want to go take a look at our new turbocharger from the mainland China. Okay, this is our new turbocharger, and as you can see that the compressor wheel is actually machined from a solid billet of aluminum. It looks like an excellent job. It will be interesting to see, how it performs. This is actually supposed to be an upgrade from the original equipment. As far as the number of vanes and their profile, it looks very, very similar. Here we take a look at the turbine wheel. Now this looks like a brand new turbine wheel. I can see they had to do a heavy machining operation for balancing, but This is obviously a cast turbine wheel with a minimum amount of machining. This material is very difficult to machine, whereas the aluminum is very, very easy. And obviously the temperature of the air here on the compressor side is relatively cool, whereas here I'm exposed directly to the flow of exhaust gases. All right, we have a brand new compressor housing, and we want to make sure that the clearance is good and tight and make sure there's no interference. It looks very nice, no problem there. When we actually look at the design of our turbine housing, okay, when we look at our turbine wheel, this has the 9 blades. Now this is a dual nozzle, or sometimes they call it twin scroll, but what happens is I actually have 2 nozzles, 2 cylinders. They're going to be pushing here against the blades, and obviously they have this bucket effect, so here the high velocity exhaust gas is actually going to be redirected in the opposite direction, and to do that I'm extracting a considerable amount of kinetic energy from the flow of exhaust gas, and I'll experience a considerable temperature drop there in the exhaust gas from the exhaust manifold to the area just before the catalytic converter. In fact, that's the way we would measure turbocharger efficiency, is how much energy can I extract. We measure the temperature of the exhaust before and the temperature just after the turbine assembly. Obviously, with the turbine wheel broken and wedged into the housing, I'm not going to have any difference. But here, if this turbine is extracting that energy and using it to compress the fresh air coming from the air cleaner into the intake manifold, then hey, that's what I'm designed to do. And we'll look at it in just a little while, but we also have a heat exchanger that's going to reduce the temperature of the compressed air there, increasing its density considerably before introducing it there to the actual intake manifold there at the cylinders. And remember, this is a hot V engine, so the intake manifolds are actually on the sides of the V8 engine. Okay, now this area right here, this would be the discharge of our 2 compressors. And you'll notice that they actually go to a common plenum. Yeah, this is connected together, absolutely. This is connected together, so I have a common plenum. And this is the heat exchanger. What I'm doing, I'm actually using engine coolant that's circulated through a separate electric pump in and out. It has a separate radiator, but it does use the same common reservoir as the cooling system of the engine. But what happens is obviously the coolant destined for this heat exchanger and its matched radiator stays within its coolant loop. It's just simply taking its coolant supply from a common reservoir. Now, when you look here, I do have here at the bottom, this is one of the ports for my crankcase ventilation system. And here we see another port for my crankcase ventilation system, which we'll be taking a look at here in just a moment. And here I see another port. This is part of our crankcase ventilation system. Here, as I look on the side, here I see my manifold absolute pressure sensor. Now this is a speed density system. It does not have an airflow meter. It estimates airflow rate based on engine speed and intake manifold air density, the temperature and the pressure of the air. Alrighty. Now, I'm going to go ahead and set this down, but before I do though, let me talk about this just for a moment. Here, this is one of the pipes here for our crankcase ventilation system. And the actual crankcase ventilation gases are going to the intake manifold, but they actually have a separate passage here up at the top. And this main passage, this is the primarily airflow, and this is going to be crankcase vapor after the oil has been separated from it. Now, of course, with the failure mode for this vehicle, this was just loaded up with engine oil. This has all been washed out with solvent and blown dry. So here it's ready to go back on. Now the next thing we want to take a look at is the crankcase ventilation system. All right, this is actually the crankcase ventilation system here on the Audi 4.0 liter. And as you can see, there's quite a bit to it. And what it does is it has a coarse oil and a fine oil separator. And the idea is what it's doing is it's separating oil from the crankcase vapors, and it's sending the oil back to the crankcase. And then the idea is it's going to send the crankcase vapor there to the intake manifold. And we saw that passage just now. Now, let's take a look over here, and this is the old one. Here's the old one. Now, I think that this had actually been replaced once in the life of the vehicle, so there's probably nothing wrong with this. But then, since this is so prone to failure and actually doesn't cost that much, I thought, well, hey, let's go ahead and freshen it up. So we got a brand new one. Okay, here we see the main oil feed, and of course we talked about leaving out the screen and the check valve, so now I'm connected directly to the main oil gallery. And you can see that the oil line is not very long. We carefully cleaned and have blown it out with shop air, so there's absolutely no problem. And if you can see in here, you'll notice that I have 3 orifices. One's going to the rear seal, the other one's going to the thrust plate and front seal, and then the center one there goes to the bearing cartridge, or the bearing. So as you can see, there's already an orifice there. So I have a metering of oil. I want to have full mainline oil pressure here at this port. Now obviously, with this nice fresh turbo, the clearances are very small. So there we go. So I should have minimal leakage, and then here of course is the oil drain back to the crankcase. Now of course you're looking there, you see these an additional 2 passages. This is for engine coolant. So engine coolant also circulates through the housing to help control the temperature of the turbocharger and prevent the oil from coking and burning. Alright, so here we are, all ready to go. Feels real nice. Minimum play, minimum clearance, so we're ready to install it on the vehicle. Okay, here we've completed the assembly of our new turbochargers and taken the vehicle for a thorough road test. Now we'll be actually taking this vehicle on a long journey of probably about 1,500 miles, so we'll be able to evaluate performance and oil consumption. Now the check valve and the screen that is in the path there from the main oil gallery to the oil feeds there at the turbochargers have been removed. So these turbocharger oil lines are connected directly to the main oil galley. So as soon as I develop oil pressure, I have a flow of oil coming up here to the floating bearings and the thrust bearing. Now obviously I have a large drain passage going back to the crankcase from the turbocharger bearing housing, and that's what of course damaged these turbocharger, was starving of oil. That screen is gone, the check valve is gone. I did order a upgraded screen and an upgraded check valve, but after looking at them I thought, why are they there? Many other manufacturers with this style setup, they don't have any type of screen or check valve. The check valve is designed to prevent the oil from draining back, but hey, this line is less than 1 foot long. It's only about 8 inches long. So hey, how long does it take for the oil to come rushing up to these bearings there on my initial crank? All right, now like the BMW and Mercedes, what are we doing here? My wastegate actuators are actually vacuum controlled, and I actually have to apply a vacuum to close the wastegate for turbocharger boost. And here we see the right side and the left side. The actual turbine housing on the left side, this whole manifold was replaced. We went ahead and opted for the old one here on the left side. And one of the things we had to do is, of course, replace these studs. These are the specific studs for an exhaust manifold. These are actually from a Ford 4.6 liter application, but they work very nicely here in our application. 8mm 1.25 threads. So, and of course, you know, it's designed specifically for an exhaust manifold application. Okay, so here we see on our Audi the fresh air is coming up through our cylindrical air cleaner, which is freshened up, brand new, coming into the inlet of our two compressors. The discharge of the compressors is actually going to a common plenum, and you'll notice that I have these bypass valves. So on rapid deceleration, what I can do is I can just simply vent the output of the compressor back to its input. So here, preventing a surge during a hard acceleration and rapid deceleration, or rapid closing at the throttle. So here I can quickly modulate and control the boost pressure here before the throttle blade. And I have a boost pressure sensor on each of these plastic housings, and you can see it, and here's the solenoid that actually controls the bypass. Now you'll notice that I do not have a mass airflow meter here. This is actually a speed density system. I have a manifold absolute pressure sensor that's hiding down here on the side of the heat exchanger, and I have two inlet air temperature sensors, and they're actually on the lower side of the throttle body. This is actually, their harness going to them is actually kind of stringing down underneath. It's kind of hard to see. Here we see our crankcase ventilation hose, and I do have a new crankcase ventilation cavity, I should say. What it is, it's the oil separator, so it's separating the oil from the vapor and then directing the crankcase vapor there to the intake manifold. And here, as I go through the heat exchanger, which by the way has a common plenum, both turbochargers feed into a common plenum, so there's no separation there. After we pass through the heat exchanger, the actual intake manifold on this Audi is actually this plastic assembly up here in the front, and goes to the plastic intake manifolds here on the left and right sides of the engine. And of course, since this is relatively cool air, it's all made out of plastic. And obviously, with this design, the exhaust system is there going to the center. That's why they call it a hot V design. And here I see my catalytic converters just beyond the turbochargers. Well, here, just kind of sum up real quick. Here we have a high pressure fuel pump for the left and a high pressure fuel pump for the right side. This is direct injection. The injectors are kind of hard to see. They're kind of tucked in here underneath the intake manifold. I can't see them directly without doing some considerable disassembly, but they're actually injecting fuel directly into the cylinder under high pressure. And let's see what else we have here. Now, one thing that's interesting is the coolant flow through the heat exchanger between the turbochargers and the intake manifold has its own separate pump and its own separate radiator. But it does still use a common reservoir. Now remember, I'm actually filling this cavity through the pump. Or I should say I'm filling the heat exchanger and the radiator using the pump and drawing the coolant from the coolant reservoir. Now once this coolant is introduced there to the heat exchanger and its radiator out front, it no longer circulates through the bottle. It just might expand and collapse a little bit, but very little circulation. And then of course here we see the main reservoir that's going to be for the engine cooling system. Now it really wasn't too bad trying to bleed air from this system. The water pump is actually driven by the timing chain through a shaft, and the water pump is accessible there in front of the engine. Kind of hard to see right there. There is an air bleed that's hiding up here behind the cowl, which we did make use of. That's actually in the heater hose line going to the 2 heater cores. And I do have a separate circulator pump for the heater cores, which I did replace. It was defective, and we put a new one on it. So that seems to be working fine. So we're going to go ahead and take it out here for a short drive, but as I mentioned, we're going to be taking it for a long extended trip, and we'll be able to evaluate the performance and see how she does. Just initially though, tremendous improvement. Glass smooth idle, very powerful. So we'll be looking forward to driving the car for high speed at long distance. Now, of course, as we saw before, these 2 turbochargers were made in mainland China. The compressors are machined from a billet of aluminum, not cast. And of course, when we look at what we had, it looks like the housing, the bearing cartridge housing, the compressor housing, the compressor wheel, obviously the shaft and the turbine wheel are all brand new. It did look as though the actual exhaust manifolds and turbine nozzle here were in excellent condition. There's nothing wrong with them, but I don't think it was brand new. I think it was just remanufactured. But one of the things that we were missing that was a nuisance was these studs right here, which of course we have new ones. They're not exactly what Audi calls for, but the threads are exactly the same and they fit very nicely.